GeopByte.
Welcome to GeopByte. Hi students. In the previous video, we have covered the topics example problem 10 and exercise 1.3 problems from 1 to 3. In this video, we are going to complete the exercise 1.3, that is the remaining problems from 4 to 9 are covered. Now, let us see fourth question. Express 0.99999 and so on in the form P by Q. Are you surprised by your answer? Let us see. See, first let us assume 0.99999 and so on is equal to x. Now let us multiply 10 on both the sides because here only one digit is repeating. So it is 0.9 bar. So we have bar for only one digit, that is why we are multiplying 10 on both the sides. Now 10 into 0.99999 and so on is equal to 10 into x. Now see, if we multiply 10 to this number, it moves one digit towards left. So 9.9999 and so on is equal to 10x. The point moved one step towards left. So 9.9999 and so on is equal to 10 into x, 10x. Now if you see 9.9999 and so on can be written as 9 plus x. Let us see. See, 9 plus x is nothing but this one, that is 0.99999 and so on. If we add 9 plus this one, 9 plus 0, 9 point, the remaining numbers are written and so on. We got the same 9.999 and so on. So now in this place we can write 10x is equal to 9 plus x. Now if this x comes towards left, 10x minus x is equal to 9. 10x minus x, 9x is equal to 9. X is equal to 9 by 9. Therefore, x is equal to 1. If you see, we got x as 1. That is nothing but 0.9 bar is equal to 0.9999 and so on is equal to 1. See, we need to get in the form P by Q, but we got 1. So, this is the surprise. That is nothing but, see, the difference between 1 and 0.9999 and so on will be 0.0001 and so on. So, this is the negligible difference. So, 0.9999 is called as 1. That is why we got the answer 1. Now, let us see fifth question. What can be the maximum number of digits be in the repeating block of digits in the decimal expansion of 1 by 17? Perform division to check the answer. Let us perform division. We have 1 by 17. So, 17 will be divisor and 1 will be dividend. If you see 1 is smaller than 17, we cannot divide with 17. So, 0 point. Now we can put a 0. After putting a 0 also, 10 is smaller than 17. Again we need to put a 0. So for that we need to take a 0 and here 0. For decimal point we get only 1 0. For one more 0 we need to take 0 in the quotient. Now 17 5s are 85. So 17 5s are 85. 100 minus 85, 15. Now let us take a 0. Now 17 8s are 136. (150 minus 136). It is 14. Again let us take a 0. Now we have 140. So again 17 8s are 136. Now 140 minus 136 gives you 4. Now let us take a 0. Now 17 2s are 34. 40 minus 34, 6. Now let us take a 0. Now 17 3s are 51. 60 minus 51, 9. Now let us take a 0. Now 17 5s are 85. 90 minus 85, 5. Let us take a 0. Now 17 2s are 34. 50 minus 34, 16. So we will put a 0. We are putting these all zeros because they are less than 13. That is why we are putting zeros with this decimal point. Now we got 160. So 17 9s are 153. 160 minus 153 gives you 7. Now let us put a 0. Now 17 4s are 68. 70 minus 68, 2. Now we got remainder 2. Let us continue here. 2 and let us put a 0. Now 17 1s are 17. 20 minus 17, 3. Again let us put a 0. Again 17 1s are 17. 30 minus 17 is 13. Now let us put a 0. Now 17 7s are 119. Now 130 minus 119 is 11. Let us put a 0. Again 17, 6 are 102. 110 minus 102, 8. Again let us put a 0. 17, 4s are 68. 80 minus 68 gives you 12. Let us put a 0. Now 17, 7s are 119. 120 minus 119 gives you 1. Now if you see, we started with 1. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 digits. They asked how can be the maximum number of digits we get as the quotient, that is repeating block of digits. We got 16 digits repeating. See, we got remainder 1. So after here, again we need to put a 0. Again 10 is smaller than 17. Again we need to put a 0 here and take another 0. So it will be similar to like this, and again it starts from here. So we got 0.882947 bar. Now let us see sixth question. Look at several examples of rational numbers in the form P by Q, Q not equal to 0, where P and Q are integers with no common factors other than 1 and having terminating decimal representation. Can you guess what property must Q satisfy? Let us see. First, we observe that when Q is equal to 2, 4, 5, 8, 10 and so on, when Q is 2, 4, 5, 8, 10, when Q are of this type, we get terminating decimal representation. Let us see with some examples. Let me take 1 by 2. Here we have Q is equal to 2. Now 1 by 2 is nothing but 0.5. So it is a terminating decimal expansion. And we have denominator Q is equal to 2. We have only 1, 2. So that is nothing but 2 power 1. Now let us see some 7 by 8. It is nothing but 0.875. So it is a terminating decimal expansion. And the denominator is Q. See, here we have 8. 8 is nothing but 2 into 2 into 2. 2 2s are 4, 4 2s are 8. So that is nothing but 2 power 3. So here Q is equal to 2 power 3. Now let us take 4 by 5. It is nothing but 0.8. Now denominator Q is equal to what we have? Only 5. So 5 power 1 since we have only one 5. Now if you see, here we all got terminating decimal expansions. And if you observe the denominators, we got in the powers of 2 and 5. So here we observe that when we need to get terminating decimal expansion, the prime factorization of the denominator of a fraction should has the powers of 2 and 5, right? 2 and 5. Then only we will get terminating decimal expansions. That is, the Q must have powers of 2 and 5. Now, let us see 7th question. Write 3 numbers whose decimal expansions are non-terminating, non-recurring. See, we know that all irrational numbers are non-terminating and non-recurring decimal expansions. So, let us take root 3. Root 3 is an irrational number. So, the decimal expansion of root 3 is 1.732050807568. So, this is non-terminating, non-recurring decimal expansion. Now, let us take root 26. So, it is 5.099013592. So, this is the decimal expansion of root 26, which is non-terminating, non-recurring. Let us see one more example, root 101. That is nothing but 10.0498756212. So, root 101 also has a decimal expansion which is non-terminating, non-recurring. So, hereby we conclude that all rational numbers decimal expansions are non-terminating, non-recurring. Now, let us see 8th question. Find 3 different irrational numbers between the rational numbers 5/7 and 9/11. Now, let us find decimal expansion for 5/7 and 9/11. 5/7. 7 is divisor, 5 is dividend. If you see, 5 is smaller than 7, so 0.0. Now, 7 sevens are 49. 50 minus 49, 1. Put a 0. 7 ones are 7. 10 minus 7, 3. Now, again put a 0. 7 fours are 28. 30 minus 28, 2. Again 0. 7 twos are 14. 20 minus 14, 6. 0. 7 eights are 56. 60 minus 56, 4. 0. 7 fives are 35. 40 minus 35, 5. So we got 5. Here also we have 5. Again this will be repeating. So 0.0 91425 bar. Now let us do for 9 by 11. 11, 9, 0.0, 11 eighths are 88. 90 minus 88, 2. Now put a 0. 11 ones are 11. 20 minus 11, 9. Again we got 9. Again we will put 0, 88. Again this will be repeating. So our quotient will be 0.81 bar. Now in between these two decimal expansions, we need to find the number of irrational numbers. They asked to find 3 different irrational numbers between 5 by 7 and 9 by 11. So in between these two decimal expansions, we get 0.73, 0, 73, 00, 73, 300 and so on. This irrational number lies in between this decimal expansion and this decimal expansion. And one more can be 0.75, 0, 75, 00, 75, 000 and so on. This is another irrational number between 5 by 7 and 9 by 11. And one more can be 0.79, 079, 0079, 000 and so on. So these can be the 3 irrational numbers in between 5 by 7 and 9 by 11. Now let us see 9th question. Classify the following numbers as rational or irrational. Below we have some questions. We need to classify each question whether it is rational or irrational number. Let us see the first question. We have under root 23. Under root 23 is equal to 4.795831523331 and so on. Now if you see the decimal expansion of root 23 is non-terminating and non-recurring. So it is an irrational number. Let us write non-terminating, non-recurring. So it is an irrational number. Now let us see second one. We have under root 225. As we know, under root 225 is equal to 15. And 15 can be written as 15 by 1. So it is written in the form of P by Q, and P and Q are integers where Q not equal to 0. So it is a rational number. Written in the form of P by Q, where P and Q are integers, Q not equal to 0. Now let us see third one. We have 0.3796. We don't have and so on. So it is a terminating decimal. So 0.3796 is terminating decimal expansion. So it is a rational number. Now let us see fourth question. We have 7.478478. Let us write 7.478478. Now if you see, this is non-terminating but repeating decimal expansion. It is non-terminating but repeating or recurring, right? Repeating or recurring decimal expansion. So it is a rational number. Let us see the next question. We have 1.10, 100, 100, 140, 1 and so on. Let us write 1.10, 100, 100, 140, 1 and so on. If you see, this decimal expansion is non-terminating, non-recurring or non-repeating. So it is an irrational number. It is non-terminating and non-recurring decimal expansion. So it is an irrational number. The remaining topics will be covered in the next video. You are welcome to contact us on Telegram to clarify your doubts regarding these topics. Check out the link in the description. Thank you for watching. Please do like, share, comment and subscribe to GeopByte.
GeopByte.